This episode of Serverless Chats is sponsored by New Relic and Epsagon. This week, I recap AWS reInvent 2020 with the help of 8 amazing AWS heroes. This is Serverless Chats, episode number 86. Hi everyone, I'm Jeremy Daly and this is Serverless Chats. Today we have an absolutely amazing episode for you. reInvent 2020 is finally done. We're in February of 2021 and unless they decide to maybe stick another week of videos in, reInvent 2020 is finally done. So I figured why not do an episode where we can get the best input and the best insights from some of the most amazing people in serverless. So today I have 8 AWS heroes with me, and we are going to talk about all the amazing things that happened at reInvent 2020. So I'm just going to go quickly around the horn here and introduce everybody. So first up is AWS Serverless Hero, independent consultant, developer advocate at Lumigo, host of the Real World Serverless podcast, the Burning Monk himself, Mr. Yan Cui.
Hey guys.
All right, next we have an AWS community hero. He's the technical evangelist at Atlassian and the guy who once helped me stalk Werner Vogel's just so we could get a photo with him, Mr. Serhat Can.
Hey folks, happy to be here.
And next is another AWS serverless hero. He's the CTO of Neurosperience, co-founder and co-organizer of just about every serverless community event in Italy, the Italian stallion of serverless, Mr. Luca Bianchi.
Hello.
All right, next we are joined by yet another AWS serverless hero. He's also the CTO at Epsagon and way too smart for his own good, the man they call Mr. Observability, Ribenzaft.
Hey, everyone.
All right, moving on, we have another AWS serverless hero. He's the VP of engineering at Theodo, editor of Serverless Transformation, and an excellent Nashville, Tennessee drinking buddy, Ben Ellerby.
Hey, Jeremy, thanks for having me.
All right, next up, another AWS serverless hero. She is the Alliances and Ecosystem Director at Stackery, a co-organizer of Serverless Days Virtual and several other serverless community events. My good friend, the amazing Farrah Campbell.
Hi, everybody. Thanks for having me, Jeremy.
All right, next we have an AWS serverless hero and senior engineering manager at the Lego Group. He's a serverless speaker, an amazing writer, and all-around awesome guy, Mr. Sheen Brisals.
Hey everyone. Thank you, Jeremy.
And finally, we have an AWS machine learning hero to round out the panel. She's a solutions engineer at Liberty IT and a co-conspirator in the Werner stalking incident with Serhat and me, the absolutely brilliant Gillian Armstrong.
Thanks, Jeremy. It's good to be here.
All right, so we have 8 amazing people right now, all kinds of knowledge that they can drop. So what we're going to do is we're going to go through each person. I'm going to just give you the floor. I want you to introduce something interesting from AWS, whether AWS reInvent, whether it was an announcement or something that happened. Just tell me about it. So let's start with Yan. What's your favorite thing that happened at reInvent?
Yeah, sure. I think probably the biggest one, the biggest announcement reInvent for me was Aurora Serverless V2, which really is a bit of a marvel when it comes to engineering excellence. Some of the things you can do with Aurora Serverless V2 in terms of the instance scaling and really fine-grained steps of how quickly and how much you scale up. Solves a lot of problems that Aurora Serverless V1 had that people actually want to use in production. And the things just takes forever to scale up, and you go in the big double increase in size, which in terms of cost is probably not the most pay as you go, because you're not doubling your costs straight away.
Right.
So I'm quite excited about what they're gonna do once it goes GA on the Aurora Serverless V2.
Yeah. And what do you think about the cost aspect of that? Because that was one of the things where you look at those ACUs and they've actually doubled the cost of those. But do you think that just the benefit of having all those features and how quickly that's going to scale? I mean, because it scales instantaneously. Do you think that's going to be a good trade-off from a sort of a financial standpoint?
I guess we still have to see what happens once people start using it in production. But because of the fact that they've reduced the unit that you scale up by, because before you have to scale from 4 to 8 to 16 to 32, and that means you end up spending a lot of money on ACU that you're not going to be using because it's just
Right.
over that 8 ACU and you just need 8.5, but you end up with 16. And the fact that it takes longer for them to scale down also means that you end up paying for overhead that you don't need for longer as well. So besides all the extra feature you get, the fact that it's more expensive per ACU doesn't necessarily mean that you end up paying more overall because you cut down a lot of the waste that you have. So I guess it's still waiting. We still have to see in production what actually transpires. But given the fact that it's now can scale a lot faster, which unlocks use cases that just you couldn't do before. Before It just takes too long to scale up, and some of the extra features they talk about in terms of what's it? I've got some notes here. Some extra features like. Right. So there's some stuff that was missing before, like a global database, the IAM off, and the Lambda triggers. So all of those now are become available in the Aurora Serverless V2, where they were missing on the V1. So between that and the fact that you cut out a lot of your waste, I suspect that it's going to make a lot more financial sense to go to V2 going forward.
I'm curious by the way why it's named V2 and not just, hey, we've updated the Aurora and it's now better. Like, it's the first time I've seen that they nickname it V2. Is it something that happens behind, or like what's the reason?
Or maybe Aurora truly serverless or something like this.
Yeah. I think it's because that it's a complete set of a complete new offering, and the fact that you can use V1 and V2 side by side. So it's not a complete replacement of Aurora Serverless, but it's a new imagining of how Aurora Serverless should work, which is why it's V2. And you can actually have the same cluster with both V1 and V2. I'm not sure how that's going to work in production in terms of predictability and everything else. Like, okay, some stuff will work with the new features like Lambda triggers, and some won't. I'm not sure how that actually plays out in the real world. But at least you have that option of running the two versions side by side, which might make migration a bit easier, so that you can gradually move stuff over, as opposed to stop one day at downtime and then bring up a new V2 and then see what happens.
Right. And thinking about some of those use cases, like, anybody have any thoughts on maybe, when people could say, hey, with this level of scalability now, what use cases could I maybe start migrating to serverless that I couldn't before?
I would think that the lowest scales would really fit the Aurora Serverless, because honestly, you don't care about much as the infrastructure, and you do care for every bit that you're paying, and you do care about the instantaneous scalability. So I think for the lower scales it makes sense. On the other end, the more bigger scales, billions or hundreds of billions of requests or rows every day, it's something that probably serverless wouldn't be the best fit for. That's my opinion.
Yeah, I think they have to be factored into account how much engineering expertise you have to actually do that yourself. Because one thing that's always gets left on the table is, well, if I have to hire somebody to do this for me to run on containers, that's going to cost me 20 grand a month. How much am I actually saving if I saved 10 grand a month on the AWS cost and spend double that on the staffing cost? So again, if you got expertise already, then yeah, I think you're absolutely right. But if you have to hire expertise from externally, then you have to factor into account the total cost of ownership, not just the cost of your AWS bill.
The other question is, when should I choose RDS and when should I choose Aurora now? Except for if I want an Oracle database or something which is traditionally old, but for MySQL or Postgres, why should I even bother RDS anymore?
It's a good question. Does anybody have an answer to that?
I mean, Aurora does give you some really amazing features that you have to build yourself, which are quite hard to configure and set up and all of that. Things like a global database, the fact that you've got Lambda triggers, you've got IAM authentication, which I still have a problem with that, because you still need to have a root access. You still need to have a root user, so you have to still have that security overhead of having to maintain that and deal with that. So, but still, you've got a bunch of built-in features that Aurora has over just, I guess, normal RDS. What do you call it? Just a non-Aurora RDS.
Right.
And Aurora has also got some pretty crazy performance. The last time I saw some benchmarks that someone's able to get up to something like 10,000 ops per second or something like that on the Aurora, which is quite significant. It's not easy to get to that level of throughput on the RDS.
Right.
I think if you look at from a different angle, so when serverless Aurora V2 becomes popular, it will give an extra option to DynamoDB for those who are more towards a SQL. And there are use cases now, they just stuff everything in Dynamo because that is the go-to option they have. With V2, that will kind of get loosened up. And I mean, earlier this week, an engineer came to me with a design where she wanted to keep a certain audit data in DynamoDB. But when I looked at the query that she had to perform on the data, I knew that it's too much for DynamoDB.
Right.
So, these sort of situations, not necessarily, millions or billions of, transactions and things, but even that sort of, the flexibility and the ease of using without compromising the performance. So those aspects will come into play when, eventually when it becomes popular.
Yeah, and I love using RDS or even Aurora Serverless. Is one of the major ways that I've used it recently is just to store data off of streams from DynamoDB as a way that I could query it. But it was more for the admin side of things and less for sort of a front end use case. But yeah, I think that's a super interesting sort of thing that you can do is say, look, if I can mix and match those two databases together, get the operational performance and that stability of Dynamo, but then also be able to expand my query capabilities with something like Postgres or MySQL. I think that's an interesting way to do it.
Especially, and I think with the glue elastic views, which came out of reInvent as well, we'll be able to have the same data replicated across multiple data stores. I've not played around with it yet, but I think we'll be able to have application data from DynamoDB replicated to relational databases or other DynamoDB databases, but we'll be able to have data scientists interacting with those relational databases directly. At the moment, I'm particularly using S3 as a sort of serverless data lake and then using Athena to query on top of that. But it's nowhere near as powerful as a data scientist having direct access to a relational database.
Right.
There's also the fact that you can stream stuff from DynamoDB streams to Elasticsearch as well, which is such a common use case.
Right.
I literally built it like 3 times in the last 6 months for different projects, and it's just so much easier if I can just point this Elastic view, I forgot what they call it now, to between DynamoDB and the Elasticsearch. That'd be awesome.
Yeah, the problem with Elasticsearch is that it's not serverless yet, right? So we're still managing those clusters, and I mean, 99% of it's done for you, but you still have to sort of think about it. So, any other thoughts on Aurora Serverless V2?
Because one thing that's worth mentioning is that at least right now, before GA, they still don't have the data API yet, which means from a serverless point of view, you still have to worry about managing socket connection, pooling, and all of that, and maybe bringing in database proxy. But I imagine by the time they go GA, they should have added the support for data API, because that was quite a big game changer for Aurora Serverless.
Right, definitely. All right, let's move on. Let's go to Luca. What's your favorite reInvent announcement?
Yeah, my favorite announcement is the container image format support for Lambda, because this is something that was very game-changing for machine learning practitioner, but also for a number of use cases, because now we have the possibility to drop and define all the dependencies of a Lambda in a specific file format for the image that can be deployed on the Lambda. It is not a direct support for container images, so you cannot deploy containers, but you can describe in the same format everything that you want to be packaged inside with your Lambda. And it is great. It is great because it makes you able to go over a lot of constraints. It makes you able to implement tree shaking or dependency removing. and so you can optimize also the package that is deployed to Lambda, and it's something that you could have done before, but you needed some kind of serverless specific plugin, or to do this by yourself using CDK or whatever, and it was not straightforward. Right now, it's completely direct, and you can just specify the format. The other thing that is very important is that choosing a standard format, we have a lot of Kubernetes, of container DevOps engineer that now can bring their workloads to Lambda using exactly the same format. Not every feature of the language, of the format is supported. For example, you cannot open a connection to our ports to other services, or manage connection within the image, within the container. But the subset which is supported is something which is really great, because you can run even runtime scripts on the packaging machine when you are building the package. Moreover, the container support and everything that you can package to make your image working, and I'm referring about the Lambda runtime environment that can be packaged on the container, makes you able to do two things. The first one is that you can choose your own image format, so you can start from any kind of available Docker image. You can choose Ubuntu, you can choose Red Hat, you can choose Fedora or whatever kind of image. And you can package, you can start from, say, a Python image, so an image which has already a different kind of the Python environment, Python runtime bundle with that, or say some kind of Linux-based utilities such as ImageMagick or FFmpeg or whatsoever. So you can choose your base image, and you can bundle within that your runtime environment client, which has been released open source. So you can also use that feature to test locally your development work cycle, which is great, because you can run a Docker on your machine, deploying that image, make Lambda calls to that runtime environment, and then test even before pushing that to the cloud.
Yeah. No, and I think that's a good distinction too, that it's a packaging format. You're not actually running a container in the Lambda function itself. But yeah, I mean, that opens up a whole bunch of, I think, a whole bunch of tooling options. So has anybody else seen, some feedback on sort of how this helps, people that have existing workflows start using serverless?
Yeah, I think so. And I think that Gillian has some nice use cases, because we have discussed about them before.
Yeah, well, I'm mainly looking at that because we're doing machine learning. Obviously, the models are quite big. Shoving them into traditional Lambda is not gonna work out for you. So having the extra space is really nice. And it's definitely allowing us to do a bit of experimentation and see what we can do. The system I'm working on, it's got lots of different data extraction. So we need different models at different times. We don't want them all running like just burning cycles when they're not being used, because some of them will be used very infrequently. So being able to put those in a Lambda is a massive advantage. But then I do have like some concerns around the containerized Lambdas, that you're going to see companies come in, and the first time anyone uses Lambda, it's in a container, and then they never come out of the container, instead of saying, well, if I can build this Lambda without the container, I'll start there and only move into a container when the use case doesn't work for just a straightforward, simple Lambda where you get a lot more just done for you. And that can be right for some companies, but I'm wondering if people might, come from their container world, go into the container Lambdas, and never actually just go and build a plain Lambda. And that's actually all they need.
So, Gillian, I've got a question for you. Have you actually tried loading a large machine learning model in the container image Lambda function?
I've tried to load an image learning model of more than 400 megabytes. And it is a good approach if you don't need to update the model, and if you want to have some kind of immutable packaging. and it works well. It requires a bit of time when the engine is optimizing your container, because once that you push, the workflow specifically is that you push the image into Amazon Container Registry, and then you update the Lambda, or you create the Lambda referring, pointing to that image in the container registry. And when it happens, the Lambda starts pulling the image and optimizing the image, and that phase is dependent on the size of the package of the image.
So my question for you guys in that case is, have you measured the latency for reading that model?
It's not fast.
Because I was talking to someone from IKEA.com. They have the exact use case that Gillian, you're thinking about, and they're trying to load a machine image that's a container image that's 1.5 gig. So they're trying to load a machine learning model that's 1.5 gig, and it took them 4 minutes to do that in 100 megabyte chunks. Which means that if you want to load a 10 gig, like full 10 gig container image, you won't have time. Like Lambda is going to time out before you can load it. So that's something that I'm trying to figure out, is that just like something that they were running into, or it's just more of like a platform problem that they haven't figured out yet? And the trade-off they made in the design for this container image is that the container image itself doesn't matter how big it is, it gets broken up into small chunks into a sparse file system. So that's how they're able to limit the cold start penalties for loading container image. But then that means that if you actually need to load lots of files or large files from your container image, well, good luck. It's going to be pulling small chunks from from whatever, just from the file system.
I want to talk to someone who gets 10 gig in their Lambda. I think you get a prize if you manage to get a 10 gig Lambda and it's like successful and working well.
I'm also wondering how does the increased cores, now that you can have 10 gigabytes of memory in there, like does that help at all with loading these larger things, or are you still just limited by the network?
Yeah, I do wonder that as well, because even before the content, even before the 10 gig image, Lambda functions, you also had the full CPU when you're running the initialization as well. I don't know how well that whether or not that applies to the container images as well. And also, I guess one thing that's also worth mentioning with container images is that now you're responsible for the security and the update of and patching of the OS, which is something that's like 95% of us don't want to do.
Right. And are we blurring the lines even more? I don't know, Farrah, with what's going on with Stackery, I know you're working with a lot of customers that are building using SAM, but also CloudFormation and Serverless Framework and some of these other things. Is this something you're seeing, though, where people are super excited about it because they think, hey, now I can just use containers on Lambda functions? Or, is it just getting too confusing?
I think it's something that definitely excites people. I think what it does bring is, it provides it provides the opportunity to be able to reuse, images that you've already done, that will validate, build, and deliver Lambda functions, that previously you would have to set up a whole tool chain for. Right. I think it also helps, it's helping people that you don't have to jump into serverless head first. So you can make these incremental, approaches to starting to try to modernize your application, but also, it's already fitting into, you see it's like really kind of fitting into like how people are already working. And so I think that we see Amazon really trying to figure out ways to, integrate with tooling that's already there, with workflows and, patterns that are already there. You see like EventBridge has over 140 SaaS integrations now, with the Lambda extensions, that API. I really just see that while I think it's confusing, I think there's a lot of confusion when you should use this, or maybe where do you use Fargate? How is this going to be built? Does this support, does it support extensions? Does it support layers? So I think there's still a lot of questions, but I do think, it's really moving into, really trying to figure out like, how do you help, help developers with their current workflows and, and how do you, help speed that along and make that a little more seamless.
It doesn't work with layers. I've checked. It doesn't work with layers, unfortunately.
It doesn't work with layers?
It doesn't.
No.
Oh, no.
Yet.
Okay. Well, I'm sure it will eventually, right?
Probably not, because the layers is the file system is attaching to the file system you already have. But if that file system is a container, then where they're going to attach it.
Right. Well, I think the other thing that's important to remember here too is this is not, using a container as a packaging format is not an AWS innovation. IBM is already doing this. They're doing this at Azure. So a lot of these other cloud providers have done this before, but it certainly, I think that, as you said, Farrah, it certainly does help people sort of move in that direction. But then I also fear what Gillian said, that maybe people just get stuck in that. But I think it's hard to fight gravity of the popularity of containers right now.
Yeah, and also I think like 95% of people just don't need to use containers. I mean, it's like a lot of these new features they're adding. They keep adding like EFS and the extensions, all this other stuff.
Right.
They're medicines that's supposed to address specific symptoms and problems. It's not something that you should just gobble up every day because it's why not?
Totally agree. Hey everyone, I want to take a minute to thank our sponsor, New Relic. Now, if you're building modern applications, then you've got an incredibly complex architecture, which means monitoring it takes a dozen different tools. And troubleshooting means jumping between data silos and dashboards. We all know the pain, and New Relic wants to change that. New Relic's designed everything you need in 3 products. Telemetry Data Platform holds all of your data from any source. Full Stack Observability gives you one place to analyze, visualize, and troubleshoot your whole stack. And Applied Intelligence gives you automated detection and incident intelligence. Best of all, they're bucking the industry's love of complicated pricing to keep things simple and predictable. No more host-based pricing and no constant upsells for more functionality. And they're giving you one user and 100 gigabytes per month completely free. Check it out at newrelic.com. Observability made simple. All right, so let's move on. Serhat, what was your reInvent announcement?
So one of my most favorite reInvent announcements was 1 millisecond billing. And I know a lot of people are really excited about this, and I can't stress the importance of this, change enough. This is really important, and when you look at it, AWS is probably going to lose a ton of money. Probably they lost a ton of money overnight. But, and I know, from my friends, they save a lot of money overnight. And this shows how customer focused AWS is. And probably, it's not about just the money, because now, from our previous use cases, we had to run functions with more CPU and RAM, and then we are seeing like 100 milliseconds execution time, but we are paying for 100 milliseconds. Now we don't have to, so that means we can run our functions faster and cheaper. So that also means now people are thinking about like moving to Lambda is going to cost them much more, and they are going to lose some performance. Now they can choose the highest memory if they want to, and they're going to pay just the amount of execution time they spent. So this enables a lot of more use cases, and because now there are more use cases you can run on Lambda, then in many cases you don't need another container management service or EC2 or whatever to be able to run your whole services, because there are definitely cases where you need to be fast, and then you start thinking about cold starts, cost issues, a lot of other things, and then you start using containers, EKS, whatever, along with AWS Lambda, then your whole operations becomes a mess, right? So that also means it's not just about Lambda is getting cheaper. It's also about enabling more use cases.
I'm curious, by the way, if there is any case that it doesn't become cheaper. Like, is there any mathematical behind this thing that, I know, it will get more expensive?
Maybe only if you move more workloads on there. I mean, I think one of the things that I noticed with the 1 millisecond billing is it sounds really great in theory, and I am a huge fan of it. I actually, I think when we were out at AWS maybe 2 years ago, I said, could you make it maybe a 50 millisecond? Like even that would be better than the 100 millisecond. And they went all the way down to 1 millisecond, which was great. But you do pay an invocation cost, right? So even if your Lambda function is only running for 10 milliseconds, you are paying that invocation cost. And so I wonder, if you're invoking more functions because now you don't have to worry about maybe trying to squeeze multiple operations into a single function, if that was how you're trying to do some sort of optimization, that if you're calling more functions, that you are still maybe paying a little bit more because of those invocation costs.
I guess you could, yeah. I guess if you were doing batching before, now you're just doing one record at a time. You end up paying more for that 20 cents per million requests as opposed to the whatever ... small amount for millisecond billing.
And I'm sure you could just turn your couch over and find some change that'll pay for that bill anyways, because it is so incredibly low. But yeah, no, I mean, I think for a lot of different things there, the 1 millisecond for me is if you're doing some of those operations where maybe you're polling or you need to call an API, for example, being able to call an API and having to pay an extra, maybe it takes 34 milliseconds to call the API, having to pay that extra, whatever it is, 66 milliseconds, just seems like an excessive amount of time when you don't need to. And if you do that millions and millions of times, it does start to add up.
I do think that I guess my worry for the millisecond billing is more that now there's more excuse for people to prematurely optimize because they want to cut down 50 milliseconds of execution time, when in fact over the course of a month they're paying 0.02 cents for the whole thing. I mean, you're spending hundreds of dollars of engineering time on something you're never going to get your money back. So that's kind of more my concern about this millisecond billing. Before there's no point because whatever you do, you're going to pay 100 milliseconds anyway. But now there's that argument, we can save you some money.
So Sheen, I know over at Lego, your team has been a fan of using sort of the, not Lambda lifts, but sort of like a fat Lambda, I think is how you've referred to them in the past. Optimizing those because they're doing multiple synchronous things together. Have you seen a reduction in costs now that you're getting that 1 millisecond billing?
Yes, I mean things change. I was going to say actually, because I myself said that, and many people said, with the a millisecond billing, the Lambda functions are going to become single purpose, smaller, and etc. But when you have team of engineers doing Lambda functions, all day, they don't really look at things that way. They just continue as usual. I mean, from the early days of having the sort of the fat Lambda or Lambda lift, I think that's changed. Now it's more like a linear and single purpose. But even then, these days when you write a Lambda function, it's not just simply doing few things and quitting. You have structured logging in place. You have bunch of the config things getting loaded, a bunch of things read from parameter store, and you have layers and this and that. So already there are so much on top of a simple Lambda function. So that's the other side of this argument. Yes, it does benefit, but I don't think engineers are looking at that way in their day-to-day running or developing Lambda functions, in my opinion.
Right. And I think actually what Yan said too about prematurely optimizing, I think most developers aren't thinking about costs still. Even as we move to this serverless world, I mean, people are just kind of building their applications. And when it comes to speed, like maybe getting the latency down and things like that, those are decisions they'll make. But saying, we want to shave, 8 cents off of our monthly Lambda bill, like I think that's still outside of the the normal view of your average developer right now.
Yeah, the counter to the optimizing premature optimization is like there's another thought now, because it costs less. Why don't we up the RAM a bit to get a bit more performance? So that means they will end up paying more. Yeah. So it's always these two sides to this.
Yeah, well, and I think the other thing too is that like Alex Casalboni's optimizer tool, it just got a lot more complicated because there's so many different options. But all right, any other thoughts on the 1 millisecond billing?
Yeah, I'd just like to add to that, actually, because our development teams are a bit weird, Jeremy, we do put a focus on reading our billing data every week, more from an application understanding point of view, and to validate as things scale, the costing's still going to be in hand. So all of our teams get this every sprint as part of the Scrum process. So in the review, they look at the AWS bill and make decisions based off that. And for us, Lambda is never at the top of the list. So optimizing things like API gateway is probably a better use of time, although Lambda can be higher cost depending on your use case.
That's good to know, Ben, because I think I can take that back to our teams. I think that's very important because often engineering teams, they never get to see the production, building or anything. That is something that's really useful. Yeah.
Yeah, I think in practice, I see most people spend more money on the things like API Gateway and CloudWatch. CloudWatch and X-Ray is stuff that's, well, maybe not X-Ray, but definitely CloudWatch and anything related to CloudWatch is usually pretty high up in the list of things that cost a lot of money.
Yeah.
All right, awesome. So, all right, let's go to Gillian. What was your favorite announcement?
Well, there's lots of cool announcements, but step functions are definitely my favorite serverless orchestrator. I use them for lots of different things. And although Lambda is the duct tape that you can use to fix any problem, you can stick it between anything and get anything stuck together. I do like to see things simplifying. So seeing things like that Synchronous Express workflows, seeing things like being able to automatically straight from API gateway to a step function, or straight to API gateway from a step functions. I don't know, you can get a nice circular thing going on there and call. So being able to not having to put Lambda in between, obviously you could have used a Lambda to call API gateway from a step function, but now if you can put it straight in, best code is no code. So being able to just really simplify what you're putting together, simplify workflows, make your applications much, much easier and much less code and much less pieces. I think that's pretty cool.
Right. And as they always say, the worst, I guess the most dangerous part of your application is the code that you write, right? Like everything else is sort of battle tested, is there. And that synchronous workflows ties in very nicely, I think, with the 1 millisecond billing, because now with the Synchronous Express, you can do that function composition, and you can actually have several Lambda functions that run back to back to back to back as part of a synchronous workflow. And now you're not paying 100 milliseconds every time, or that exorbitant transition fee that you do with normal step functions.
I think you're going to have a much bigger problem if you do that with cold starts, though, because the idea of using Synchronous Express workflows is to attach them to the API gateway and stuff like that. And if if it's an API and that's user facing, you definitely don't want to have like 5 Lambda functions cold starting one after another. That's not going to be great for your user experience.
That's probably true. I'm wondering though, if it's one of those things where it's like regular Lambda functions, once you get them warmed up, does it allow you to do certain things? But also, I mean, even if you have, I guess if it's happening behind the scenes asynchronously, then asynchronous wouldn't be that big of a deal. But if you potentially do need to have multiple APIs called to bring back a single response or something like that, I don't know. I think that if they can speed it up, they could be the solution to the function composition problem.
What I'd like to see is they introduce some kind of a scripting language, some kind of a VTL, well, maybe not VTL, because everyone hates VTL, some kind of a templating thing where they can essentially just execute a script without it being a separate Lambda function. So that will remove a lot of the, I guess, performance concerns that I would have. I know, like I said, cold starts may not be that big an issue, but it does make your worst case performance a lot worse when you've got them stacking up after one another because it's all on the same workflow.
Yeah. It'd be great if it just warmed everything up at the start and knew all those Lambdas were in the step function, just warmed them up right away.
Right.
I mean, you could use provision concurrency, but then that becomes interesting cost-wise, and that becomes another thing you gotta worry about.
and expensive. And actually, I think that's actually a good point, though. Like just this idea, I mean, maybe going back to, Sheen, what you were saying about the fat Lambda and some of these other things, with the single purpose function, I love single purpose functions. I think it makes a ton of sense. But then on the other side of things, if you do have, multiple steps that have to happen, having those all run in a single Lambda function sometimes makes a lot of sense too. So I think AWS is pushing people towards individual Lambda functions. And look, having a Lambda function that does one simple thing is great because you can compose those, they can be reused and things like that. But without having a really, without being really well coordinated with step functions and understanding how all that stuff works, and then on the other side, like you said, Yan, like paying the penalty of cold starts if that's not a solution that hopefully gets better over time. So I guess maybe just a question for everybody. Where are you? Are we still on the fat Lambda if need be camp, or have we all moved towards the single purpose?
Yeah, I've seen two different approaches from people. On one side, you have people that are refraining from serverless, refraining to embrace managed services and whatsoever, and they tend to embrace fat Lambda or Lambda-lets as much as they can. On the other side, you have a lot of people that are enthusiastic from the possibility to package very bunch small pieces of code within a Lambda, and they would like to Lambdalize everything. And we are trying to have some difficulty in tying the balance in between them, because my problem is not about having a huge Lambda or having a fat Lambda, but is related to the fact that it pushes the developer to adopt some kind of bad practices about having just one CRUD service with everything inside, and you package everything within the Lambda, and maybe you just use 3 methods of that CRUD, but it's super simple to package everything within your Lambda, and who cares about that? But when you go into production and you measure cold start, you are being hitting hard in the head by the cold starts. And it's something about related to the behavior of the developer. And I think I'm more shifted about having smaller Lambdas, because it encourages you to adopt things like good patterns and good architectures. But it's not a dogma. It's more rather than something that I like more.
Well, I'm curious to get your perspective, Ron. I mean, you're the one who's looking at these functions being run. Is it easier to observe a single purpose function where only one thing's happening, or trying to, parse through those stack traces when you get errors on the Lambda lifts?
It's some and some, for the easier use cases, for, the simple exception that you're having. So, having a monolithic Lambda is very easy to troubleshoot because all encompassed in, single location. You can see everything from the beginning all the way to the end, in a kind of a single node. But when, on the other side, when it's getting complex, when you're having pipelines of, 3, 4, 10 functions with different services, different third parties and API calls, these problems tend to be more complex. And, you kind of want to see just an encapsulated problem, like, the call to Stripe was erroneous, or, something in the payload was changed throughout the course of time spent. This thing that you can't see in a monolithic, because all the logic is internally. Everything happens internally in a single function. There is no outbound call that says, okay, I analyze some data, I'm passing it to the other service that's responsible to charge that specific user, but everything happens internally. So the upside to having more microservices approach, or more event-driven, and breaking the functions into smaller pieces, is that if you're having the right tool, you will have greater visibility into what happens, because you know that at this point, when you try to charge the user, the input was X and something was missing from this specific input, unlike monolithic. By the way, at Epsagon, we were having both cases. We're still stuck with some Flask Zappa function that is having, kind of our fat Lambda. But except for that, we got, 600, 700 functions, different services, all try to be as small as possible. Someday we will migrate our fat Lambda.
I think there's some limitations that within, I guess, with things like I find with Kinesis, that's probably one of, well, Kinesis and DB streams, that's probably one place where I can't really quite follow single responsibility functions as much as I like, because of the fact that you have to contend with constraints on how many subscribers you can have, and at the same time there's no filtering, so you end up having to do a lot of filtering in your own code if you want to be handling just one type of event when you've got like event bus that funnels everything to you in one stream. So I think besides that, I think most other cases I've found single purpose functions has definitely been ideal. I've seen some clients just got fat functions. I tell you, like Rand said, all the errors is happening in one function. You have no idea what happened going on.
A lot of console.logs.
Yeah, everything's in that one log. All the alerts, one function. Every single alert message.
I agree with Ran was saying, because initially many teams, when they start, they want to put everything together, cost and so many things. But then when it gets to production and running mode, that's when the observability problem hits. They want to see what's going on. That's when the reality hits, and they wish everything was granular and isolated, so get more visibility. And that is the case actually, because when you have a production environment, you need to know what's going on, especially with all the different the features. Now we have all the destinations and keeping track of errors and things like that. So that's an important thing.
Right.
And I have some anecdotal example from Luca's example as well, where I've got a client that had this one API that's doing one endpoint was doing the server-side rendering. Everything else just a simple get and the put from DB CRUD stuff. Every single function, every single code style is at 1.5 seconds because of the React, because of that one endpoint that does the server-side rendering. So that's where that one function is easy, but then you end up paying the co-star for every single endpoint.
Right. And I'm curious from your perspective too, Farrah, because again, I know you're seeing a lot of, you're working with a lot of companies who are doing this stuff. Is that something that you're seeing as well? Is there sort of a mix and match of the single purpose versus the Lambda Lith / fat Lambda people? And I don't want to fat Lambda shame anybody. I certainly don't want to do that. So, but I mean, again, I use them sometimes too, but I'm just curious, Farrah, what's your experience?
Yeah, I think we definitely see a mix of both, but I think the goal, for our companies, people want their environments to, become more flexible, and that's the whole goal of modernizing. And if you have a big fat Lambda, is your architecture flexible? I'd have to say that probably is not. So, I think we really tried to, work towards, I would say more single purpose functions, but definitely you see a combination of both.
Awesome. All right, so let's move on. Sheen, what was your exciting announcement from reInvent 2020?
There are a few things, but one of my favorites is with EventBridge. Now we can archive and replay events, and I'll tell you the reason why I like this, because EventBridge, we started to adopt EventBridge as soon as it came out. And then at 2 or 3 occasions in different use cases, when I spoke to teams to use EventBridge, there were, a resistance. The simple reason being, what happens if I lose an event? What do I do? Especially when it comes to sort of the critical events that, say, carries customer order data or payments details and things like that. So in such situations, you can't, just go without any proof. So I had to back off in those situations and use EventBridge in other scenarios. But with the archiving replay mechanism, we get that much of, sort of a confidence that, okay, so you have your, events here. If something gone wrong, or if your, the consumer or the target Lambda, for example, had issues, it gives us the flexibility to replay those events as and when we need. So that's an important thing which was missing until the announcement. Now, I wouldn't say I had a brief look at the archive and replay setup. It's not completely clear to someone who is coming in, because you may end up replaying, hitting all the targets, and you need to be careful. You are archiving for that particular pattern or that rule that you have. Otherwise, it's not going to make much sense. And also, the other important thing many people miss is that when you replay the event comes with an extra attribute to say that, oh, I am a replay event or something like that. So that again is something important to look into when we build our the patterns to filter and the rules and things like that. So so that's why this is kind of one of my favorites, especially when it comes to EventBridge.
Yeah, and I was one of a very early adopter of EventBridge, and I remember like the first thing I did was you create a rule that captures every event, and you just send that somewhere so that you have that backup. Yeah. And so adding this in, actually, I mean, it probably seems like a relatively small thing, but it really does help. And then, like you said, the ability for you to have that little extra flag in there that says it's a replay event, that's super helpful, because if you're building in item potency and some of these other things that you have to do when you maybe reprocess an event that already happened, that's a really good thing to have. Now, Ben, I know you're a huge fan of EventBridge as well. What are your thoughts on those new capabilities?
Sure, yeah. I mean, we're using EventBridge on nearly all of our projects these days. And actually, just a couple of days ago, an article went live on the AWS Game Tech blog, which talks about our use of EventBridge in the esports space. And that's Gamercraft as a company, so feel free to look at the use case. Archiving is something we've been doing ourselves for a while, so it's great to get that just done out of the box. And especially as a lot of our clients are in the regulated space, it's great to have things like archive history out of the box as well, as we're starting to get things like last year, the encryption at rest support. These can start to be used in more regulated industries. Replay is also great. And just before reInvent, the introduction of retry policies and dead letter queues means we're getting a lot more robustness straight out the box. We're already using it on a lot of our projects, and not something I'm particularly using it for, but if you're using an event source-based architecture, obviously archive and replay are going to be crucial parts for you.
Yeah, I mean, and also the thing that is getting more and more popular with just the way people are building their applications is splitting up accounts. So you have maybe a microservice, a separate account for each microservice, for example, and you might have a separate account for each microservice and then each stage of that microservice and things like that. So cross-communication between accounts with EventBridge is kind of a complicated thing. I don't know if anybody watched Stephen Leidig's EventBridge talk during reInvent, but really, really interesting. And he just recently released some of those patterns on a GitHub repository too. But just thoughts on that. I mean, people who have had experience with this, it's kind of clunky right now, but hopefully getting better.
It's gotten a lot better already. I mean, there's still some problems with it, like the fact that it still only delivers to the default bus on the destination account and stuff like that. But at least you can now use the resource policies to control which account can access, so that you don't have to make a change on both the account where the bus is, as well as the account where the destination is. Now you can just do everything from the destination account waiting to add a new subscriber. So that was quite a nice change and make things a lot easier for people that are doing that multi-account pattern. I think one thing, Sheen, you mentioned that you talked about the archive and replay. One thing that was missing is that when you replay, they just dumps as much of the event to you as quickly as they can. So they don't respect the event ordering. So I was talking to the guys at the Mahan, this big Swedish grocery shopping company. They built some tooling around EventBridge, and they actually built this EventBridge YouTube CLI tool they've got, and that they implemented sort of respecting the timestamp, so that it gives them at the right time, as opposed to just, here you go, here's a million events, boom.
We're looking at EventBridge. Definitely very interested in it, in starting to use it more and more. But I suppose I'll ask the people who are using it. So how do you feel about sort of the observability? That does seem to be a little bit lacking in the EventBridge. Your logging, even with the new archive, I don't know if you can really use it to query and find out what's happening. And if events haven't been picked up by any rules, you don't really know that they haven't. If we only had someone here who knew about observability.
Yeah.
So we do add support for EventBridge a while back, and I think I don't know if Epsagon has support for it now. Okay, So with Lumigo, you can definitely just go to the Explore page and then just query any data that Lumigo captures for you, including stuff that traverses through EventBridge, and you can see your trace goes through EventBridge, Lambda, and so on. Whereas X-Ray doesn't support it yet. So I think Lumigo, Epsagon, and I want to say Tundra as well.
Tundra has it as well.
Correct me. Yeah, cool. So yeah, all this sort of serverless focused observability tools that they all added support for EventBridge a while back.
And if we go just back to the multi-account use case, we've been doing that on a lot of our projects. So we have, one AWS account per service and then one account per environment, which is great from a sort of blast radius security point of view. We also have clients who have legacy architectures. And actually, just last week, I found myself writing some .NET in a legacy system, which I wouldn't invite you to do. But this was then sending events to EventBridge in the new system. And that was a cross-account EventBridge, which allows us to do a really nice sort of strangler pattern style migration to serverless through a progressive sort of minimum viable migration style, rather than a big flip the switch style migration.
Ben, question about this cross-account event sharing. When I looked at a while ago, one thing I didn't quite like is I lose the control of transforming what I send to the other account. It was kind of forcing me to send the original event to the other account, which is not going to work in every scenario where the source of the event account needs to control what it provides to the other account. Is that still the case? Do you see issues around this?
Yeah, I think it's still the case. And in our use case, it's really two trusted systems. So we didn't really have to think too much about limiting data that was coming from the events. From a legacy system point of view, sending data to other AWS accounts, maybe we could reduce sort of the cost of doing that by reducing the data loads. But yeah, if it's untrusted systems, we still have a sort of issue around how we can try and filter the data at source rather than in the target AWS account.
Okay.
Sheen, why not? So in that case, why not just do the transformation at the destination account between EventBridge and whatever eventual processing thing you've got? Because you can still do the transformation there, right?
You mean between the two event buses, or?
No, not between the two event bus, but your event bus goes from the central account to the microservice account, and then you're going to process it. So can you not just do the transformation there as opposed to between the buses?
Mm-hmm. Yeah, could do that. Yeah. And my point was, even the point from the source event when it goes out, that's where I would prefer to have the control.
Why is that?
Say if you are sending payments data from a service that captures the payment details and tokens and things like that, I may have so many PII or data that you want to send to another account that is dealing with order or something else. So there are certain scenarios where it depends. Again, even if it's within the same department organization, it's fine. If it's going to a different department or a different organization, then it can become an issue, exposing everything from the original event.
Okay, right. Gotcha.
Ron, do you have any other thoughts on the observability of EventBridge?
If you gotta have this, because if you're using it as an event hub to all of your services, you do have to need something in place. Otherwise, it will go chaotic. Especially if you're using EventBridge, it means that your system is definite, microservices oriented. So either make sure you're following message IDs and what happened to them, or choose a solution off the shelf. Otherwise, it will get chaotic very fast.
Definitely. Hi, everyone. I want to take a minute to thank our sponsor, Epsagon. Epsagon enables teams to instantly simplify, visualize, and understand what's happening with their complex microservice architectures. With their comprehensive, lightweight auto-instrumentation, users are able to eliminate the gaps in data and manual work associated with other APM solutions, providing significant reduction in issue detection, troubleshooting, and resolution times. Epsagon aggregates and correlates data from all the third-party tools you love, delivering a single pane of glass for understanding serverless, containers, Kubernetes, and more. Engineers now know when something is wrong and can immediately trace issues to root cause before they affect production. Increase development efficiency and reduce application downtime with Epsagon. As a special for Serverless Chats listeners, if you try out Epsagon and connect your first trace today, they'll hook you up with one of their awesome t-shirts. Check it out at epsagon.com/serverlesschats. All right, so let's go on. Let's move on to your favorite announcement, Ron. And I know that this wasn't necessarily, I don't think this was announced at reInvent, but it was pre-reInvent, but I think had a major impact on what you do.
Yeah, so it's the Lambda log extensions. Obviously, I like almost all announcements, but the one that I really cared about was the Lambda log extensions. That, you're right, was pre-invent, maybe a week or two before reInvent this time. Basically, what they did, earlier this year, it's to provide the Lambda extensions with the runtime. So you can provide your own runtime and your own set of extensions on top of Lambda functions, the runtime API, and do some more things while your Lambda is running, and before your Lambda is running, and after your Lambda is running. Now, the third part of it, if I'm looking at the extensions API, runtime API, the third thing is the logs API. As we all know, in order to get a good service from most of the solutions out there that are doing either monitoring, security, observability, or any other thing to Lambda, they require some log analysis. They rely on ingesting logs and comprehend them in order to generate meaningful insights. So far, right before reInvent, or actually up to September or October, there was just one destination for CloudWatch logs. Means that it was kind of competition between how do we solve for a customer having several solutions to listen for these logs. Now, for reInvent, I do have a kind of a question to everyone. For reInvent, they announced the logs API that allows me to choose a custom destination to ship or query or get or analyze these logs, which is fantastic. It's amazing, but I think it was kind of 1 month later than needed, because around the end of September, the CloudWatch team, the part of the logs team, announced two destinations. Exactly.
Two destinations.
Like exactly what we needed for so long time. So it feels like it's kind of, I can still use the old or traditional way of streaming logs with the built-in integrations, by the way, that CloudWatch destinations got to Kinesis or to S3 or to a Lambda function, which makes good sense, or start to use the logs API. So again, this is a great extension. This is a great capability, but it seems that somebody somewhere else solved this problem for us, at least for the meantime. At some day it will be, hey, we need 3, we need 4, we need 5. So the Lambda extensions for logs is, I want to say, unlimited, or at least not limited by a small number. But that's my take on this one.
You are limited to 5 extensions per function. There's also other things to keep in mind by extensions as well, is that it runs at the same time as your function invocation. You don't have that background processing time after after your Lambda function code is finished running, which means that in practice, what people end up doing for the extension is they're doing that sort of agent model whereby they're buffering things and then sending them in batches. Otherwise, you're going to have to add delay to every single function invocation at the end, and there's no trigger, there's no signal for you to know when the Lambda function code has finished. So you don't actually know when in your extension code you can actually save to say, okay, invocation is finished. I'm going to spend 10 milliseconds to send the logs to whatever destination, which means that you have this weird batching until the next invocation, which means in cases whereby there's a gap of idle time between invocations on the worker, that means your logs is not going to go anywhere until either there's an invocation or the work itself gets garbage collected. And this gets worse when it comes to provision concurrency, because guess what? That thing is going to be sitting there for a long time before it gets garbage collected, up to 8 hours, which means if you are running provision concurrency, there's a chance you're not going to see your logs for a very long time, unless there's a regular invocations on those provision concurrency. So I agree.
When you say a long time, when you say a long time, I'm curious, how long do you mean by that? Like, what's the time frame that people could expect for that?
Up to 8 hours. So a Lambda worker has got a lease for up to 8 hours, which means for provision concurrency that gets kept around from the moment it's created. If there's one invocation at the start, okay, the logs got got buffered in the buffering extension, nothing happens for 8 hours. So you're going to see the logs at the end of the lifetime of that worker when it gets garbage collected, because that's the time when the extension gets a signal that Lambda function is terminated, is shut down. So you can now clean up, and as part of the cleanup, you can then send the logs to whatever third-party service you're using. Which means you're going to just get weird things that where's my logs? I don't see it for like 10 minutes because there's no activity on those provision concurrency.
Yeah, and you're probably the one that read all 100% of the fine print of serverless. Anything that is written on AWS, you know exactly how many hours there are for logs to stream from a provision concurrent Lambda.
As part of the release, I had to read into a lot of the extensions documentation to figure out how it works, and had some chat with Santiago, the guy one of the guys that runs the team that work on that feature. So I probably learned a bit too much about how that works than I should.
Hopefully, it's one of those things where most people don't need to know how that works. They just use Epsagon or Lamigo or Thunder or something, and they just plug it in. But I have seen some people doing real-time log streaming with that, especially in like a development environment, which is really cool. I always looked at the CloudWatch, sort of the attaching listeners to your CloudWatch logs as sort of a lazy logging type thing, because it's always delayed and it always takes extra time. So I think if you need real-time logs, that extensions API certainly gets you much closer than you were before. But yeah, I hadn't heard about that buffering problem of logs getting stuck in there. That's kind of interesting.
Yeah, I would say that, I know that you have the problem of, continuously loading logs from CloudWatch, like you try to refresh, and it seems to get longer than expected. I do say that when you're subscribing logs, it comes much earlier. Like if you're doing like a real-time processing, it will come faster than you'll see that on the CloudWatch console itself. So that's one thing. Okay. But when you're having the log extension API, it's real-time, I would say, in a matter of, milliseconds or less. It's more for, I would say, real-time analysis or gathering or batching of data. You might want to batch or gather some data, reduce or downsample or do something meaningful, and then just send, instead of all of the logs, just send, the metrics out of these logs, or alert when, a five window batch time seem to have some anomalous error. And again, it's a matter of, it's like if you can wait probably 1 second to get your log, that's probably an overkill. But if you're doing something that requires tons of data or something that is more real time, that's probably the case for it.
So, Jeremy, that's the one problem that does make it really difficult to do actually what you're talking about streaming, just because in your extension code, you're polling the log API, you're registering for events from the Lambda logs API, but you don't have the event to tell you when the function invocation is finished, as in your actual module code has finished. So you don't know when it's actually safe for you to terminate, to stop your extension, because it's got the same similar sort of polling model to custom extensions, custom runtime, where you run your extensions when the invocation starts, and then you have to say when you're ready to yield and give up. So if you're not careful, you end up just running for longer. The function finished here, but your extension is still running. So you end up causing extra delays to the Lambda invocation time itself.
Interesting.
One thing we actually did to get the logs in real time for development environments, we did this earlier, actually last year. We created our own custom runtime of Node.js. This is before the extension support came out. And then we overrode console.log, created an API gateway WebSocket directly to the developer's computer. And then we could shoot console logs directly to the developer's computer before the function finished executing, and in sort of almost real time. So if you do want to get direct feedback in your development environment, you could do this. I wouldn't suggest you do this in production, and it was a bit of a hassle to set up, but it's definitely an option.
I think Serhat, didn't you guys, Thunder, didn't you guys had something a long time ago that let you do real-time debugging against a Node runtime, essentially doing something similar? You are pushing, you're running like a Node debugger on Lambda, and then you're pushing events to someone's IDE who's listening to that endpoint.
I know, Serhat Can was doing some crazy stuff.
Right.
But I don't know the details. I don't want to know the details.
All right. Let's just hope that somebody figures it out and it works. All right, let's move on. So, Farrah, what was you got a favorite announcement?
I
or just
wouldn't know
all of
that.
them?
I would say I don't know that so I watched a lot of customer stories. For at Stackery, I was writing about like companies doing serverless success. And what like really excites me, is like as if you're like starting a product, or company today, you literally have like instant access to the compute power that enterprises, are using, to have security performance that will get you the scaling that you need. But I saw all these like talks that are talking about dealing with hundreds of 100 terabytes of data that they need to import and like these be or imported or uploaded somehow. And so I really just feel like just like watching all these, you really see like the raw power of AWS. I know there's like simply like no way that people could have done these types of things prior to prior to utilizing the cloud without spending I don't know how much money, but it'd be astronomical. So those types of things I think are just really, really exciting. And, at a time where I felt like, I felt pretty stagnant. A lot of us, we're not traveling, we're kind of stuck, to really see that innovation is still happening. And actually it's even, it's moving faster. And, people in the times of like COVID, companies were able to scale and respond to their different needs. We saw stories, like I saw a lot of stories from Liberty Mutual, Sheen, and your saw from Lego, but there was tons of them, from like Volkswagen to like Autodesk. It was just, all of that was like pretty, I guess I would say pretty powerful and incredible. This kind of didn't make me feel so stagnant.
Yeah, no, I think that's I think that the idea of the number of people that have been able to build companies in the cloud using serverless technology without having to spin up, hundreds of thousands of dollars worth of equipment to do things. I mean, especially even just some of the machine learning stuff that is getting baked in. I mean, I know I was at a small startup before, and we were barely doing anything in terms of, we were a small customer of AWS, and I think our bill every month was like $18,000. And if that, and this was what, 7 or 8 years ago, if we had if we had serverless at the time, our bill probably would have been $2,000 a month, right? And so what else could you have done? And it also means, what else can someone else do? What can a single developer do, or a small development team, or someone who's just interested in maybe experimenting with something? I mean, it opens up a lot of doors.
It definitely does. I mean, we're seeing that with startups, and in fact, soon I hope to have a couple of case studies out about this. But you really just seeing, like teams and the power that they have and the speed and how that extends their runway, and they're delivering on their roadmap a lot sooner, and just like what that feels like, and that to me is just like, it's really exciting because I feel like, we all need something to kind of hold on to right now to, get us to try to keep us moving and, engaged in what we're doing. And so those types of things really help me.
Yeah, I think that's an important point that Farrah mentioned, that the startups, they don't just, become successful simply because of the cost factor. I mean, I recently wrote a blog post. All the, the sort of the flexibility and the tooling that we, get for free or, for nothing, that allows us to move fast. That's an important thing. I watch, quite a few of these sort of real use cases at reInvent. It amazes me the different use cases and the way they use serverless. The one I liked was the Scottish Land Registry. They moved tons and tons of records of the real documents with S3 and serverless. Amazing stuff. And there was another thing which I never thought. I was watching the DynamoDB related, the talk from this famous entertainment company. Anyway, so their approach is to keep it on demand when they launch a product, because they don't know the volume of traffic and the capacity. Then once they study the traffic pattern, then they set to the sort of the provisioned capacity mode, which I never really thought, because usually you provision a table and that says you're done. You never go back and change this. So amazing stories and really cool tips for to take home.
Right. And I think that's a good point you make too about sort of setting the provisioned, throughput for DynamoDB. There are actually several services where it doesn't always have to be on demand, right? There's a few things where, whether it's provision currency for Lambda or obviously provision throughput, where you can set certain, sort of like baseline where you want to be. And there's always a lot of flexibility in that. So if it goes above it, it's still going to scale, whatever, but you can really optimize your costs as well. So even in those situations where you might say, well, if it's all on demand, it's going to be really expensive, and I have like a really flat sort of pricing model, there are ways to do that, including savings plans for Lambda. So even if you are using Lambda, quite a bit, and it's not as spiky a workload, you can still find savings in there. You just got to do a little bit of digging, but it's possible.
Yeah, it was Disney actually, the DynamoDB.
Disney. Oh yeah, Disney Plus. Right. Yes.
Yeah.
That was a good talk. Talk.
It was. Yeah.
They made the cost anomaly detection service. It went GA during reInvent, and I believe it's free. So you should definitely turn it on, because it saved me right after reInvent, because I went in and started turning things on and trying things out.
Yeah.
And
how many people have a provision table that they're wondering why am I paying this money for a provision table? All right, so I want to finish up with you, Ben. So we already talked about EventBridge, which I know is a big thing for you, but was there anything else at reInvent that really stuck out for you?
Sure, yeah. Well, EventBridge was the highlight for me, but just taking a second to think what my sort of second top pick would be. I'm actually working at the minute on a big serverless data lake project where we have data going into an S3 data lake, and we're then querying that with Athena and visualizing it in QuickSight for business intelligence. And that's going really well. But what we need to do now is more real-time insights. And we were previously doing this with some stuff going into Dynamo and querying off of that. But what came out at reInvent, and hasn't been probably the most talked about feature, is the tumbling window support for Lambda.
Yes.
So previously, let's say we had data in a DynamoDB table, which was then had a DynamoDB stream into Kinesis. We could do some processing on that data, but we couldn't really build aggregate statistics based off previous data. With this support, we can now have the stream of data coming into Kinesis, and for each sort of batch of data, we can have as one of the inputs the state of the output of the previous batch of computation.
Right.
So we could, for instance, calculate the day's sales by having the output of the previous batch and then keep adding on to that. We had a slightly different use case, and it's a little bit more complicated. But this has really helped us have real-time data coming visualized to the user.
So Ben, could you not do that with Kinesis analytics before, or is that not possible?
Yeah, so Kinesis Analytics is definitely sort of the other way to do it. And Kinesis Analytics actually had some new stuff added in reInvent, I think. When we tried to do it, we found Kinesis Analytics a little bit restricted because we weren't just doing a simple summation. We needed a bit more complex state coming from our previous execution. But yeah, there might be a way to do it with Kinesis Analytics. It was the tumbling window support was a little bit more flexible for our use case.
Okay, sure.
Yeah, and there was a couple of other, besides tumbling windows, there were custom checkpoints that were added in, the SQS batch windows, again, just all different ways that you can have a little bit more control over how you're processing your data. I think that was a big win. And I talked to Jay Nair, right after reInvent, and kind of went through some of these different things. And it seems to be the goal of AWS to basically take all these little objections of like, well, I can't, or I don't have enough control over this, or I don't have enough control over that, or whatever, and just keep adding those in. And then I think that goes back to your point, Gillian, where it's like eventually, it's just going to be a lot of configuration and maybe no code at all.
I think the SQS batch window scares me a little bit, though.
Why is that?
Because
why is that?
Because dealing with partial failures is already kind of tricky, and you
don't want to deal with 10,000 partial failures.
Yeah. How are you going to? Okay, imagine you got a batch of 10,000, when 2 record failed. How do you then know which ones to delete yourself and which ones you don't, and let it retry? If you don't, then you have to do idempotency, make sure it's done right. And how do you track 9,998 records being processed previously and 2 didn't?
Right.
That's interesting, because someone asked me the same question. I mean, not 100,000, 10,000, but even to 50 messages batch, they post the same question. You know what I did? I pointed that person to your recommendation you talk about, Yan, to manually kind of do the delete so that when it fails, you won't get everything sort of reprocessed. And that's why I like the other one, that what is it called, custom the
Custom
checkpoints.
Yeah,
Checkpoint,
right.
yeah. That helps so that you don't kind of get into this mess. Just replay that.
Right, because the bisecting of batches was great, but then you would still end up reprocessing a bunch of things. Now you can just say, if it fails at this point, I'm going to start again at that point. So that's a pretty good thing. So, all right, anyone else have any other thoughts or big things that happened at reInvent? Something you want to share? The floor is yours. Luca.
Yeah, I think that we had great announcement shifting machine learning more towards DevOps because AWS announced the SageMaker pipelines, which is great to manage machine learning model shifting from development to production. And it's something that was missed, and it's something that is filling the gap between data scientist and developer. I was having a very nice discussion with a friend a couple of weeks ago, and he told me this means that data scientists are not anymore wizards with magical books full of spells, but they are becoming engineers, and they are bringing things into production. And SageMaker pipelines goes in that direction.
Yeah. Now, I think machine learning, there were a lot of announcements with machine learning. I wish we had more time. We've already been talking for a while. I try to stay away from machine learning, but it's maybe just because I watched The Terminator too many times when I was a kid, and I'm just very nervous of Skynet becoming self-aware. Anyways, let's leave it there. Everyone, thank you so much. Sheen, Serhat, Gillian, Yen, Ron, Farrah, Ben, and Luca. This has been absolutely amazing. 9 people may have been too much. I don't know, we might have to cut it down next time, but I appreciate all your insights. I am going to put in the show notes links to Twitter and information on all of these amazing people that were on the show today. Thank you for watching. Thank you all for participating. And we will see you next time.
Thanks, everyone.
Bye.
Thank you very much.
And that's this week's Serverless Chat. I want to give a huge thank you to Yen Trey, Serhat Can, Luca Bianchi, Farrah Campbell, Ron Ribenzaft, Ben Ellerby, Sheen Brisals, and Gillian Armstrong for being my guests, and to our sponsors, New Relic and Epsagon. If you want to check out the show notes and a full transcript of this episode, you can find them at serverlesschats.com/86. For more Serverless Chats, subscribe, sign up to be an insider, check us out on YouTube, and follow us on Twitter, Facebook, and Instagram. You can connect with me on Twitter at Jeremy_Daily. And if you want to keep up to date on everything serverless, make sure you subscribe to the Off by None newsletter at offbynone.io. Thank you so much for joining me, and I look forward to chatting with all of you again next week.